Look around the modern wellness landscape and you will inevitably see this: a massive, perfectly raw, entirely fat-free bowl of greens. On the surface, it looks like the absolute peak of human health. We have developed a hyper-reductionist habit of tracking our protein down to the gram and hunting for isolated vitamin extracts. But treating our diet like a math equation ignores how human biology actually processes these compounds. If you eat those nutrient-dense greens completely dry, a vast percentage of their most critical health-promoting compounds will pass straight through your digestive tract and exit your body entirely unabsorbed. This animation shows a microscopic cross-section of the intestinal epithelial lining. The human gastrointestinal tract is not a passive sponge that automatically soaks up everything we swallow. Instead, it acts as a strict, highly selective gate, where most raw nutrients simply bounce off the barrier or flow right past. To successfully cross that cellular wall and enter your systemic circulation, nutrients have to be actively transported, chemically altered, or bind to a specific carrier molecule. To actually benefit from our diet, we have to shift our focus from what we eat to what we absorb. By utilizing the biological concept of food synergy, we can strategically combine specific whole foods to bypass the body's natural bottlenecks. Let's look back at the vibrant red and yellow pigments in those tomatoes and bell peppers. These are carotenoids, powerful cellular antioxidants that protect our DNA and reduce systemic inflammation. But carotenoids are lipophilic, meaning they are exclusively fat-soluble. In a dry, fat-free digestive environment, they hit a biological dead end. When you add a generous drizzle of a high-quality fat, like extra virgin olive oil, you create a mechanical trigger. Your gallbladder detects the lipid and instantly releases bile. Bile acids emulsify dietary fat into microscopic spheres called micelles, rapidly encapsulating carotenoid particles. Inside these lipid structures, the body ferries antioxidants across the intestinal barrier into the bloodstream. This healthy lipid vehicle skyrockets absorption by over 400%. Dietary fat serves a vital mechanical purpose. It is the fundamental vehicle required to extract a vegetable's defensive compounds. A similar mechanical obstacle applies to plant-based sources of iron, like a bowl of lentils or a bed of spinach. Plant-based iron, known as non-heme iron, naturally exists in a stubborn ferric state, chemically written as Fe3+. The human intestine struggles heavily to absorb iron in this specific configuration. Plant foods contain anti-nutrients called phytates. As seen here, they form a rigid, cage-like structure that tightly binds the iron molecule, locking it away from the digestive tract. Ascorbic acid, vitamin C, provides the reducing power needed to break that cage. When you squeeze fresh lemon juice over your meal, you are introducing a highly potent chemical reducing agent. In real time, the vitamin C actively donates an electron to the trapped iron. This instant transfer converts the stubborn Fe3+ into a highly absorbable ferrous state, Fe2+, instantly shattering the phytate cage. Vitamin C forms a stable, soluble complex around the newly freed iron, shielding it from any remaining phytates in the stomach's acidic environment. Adding citrus to a non-heme iron source increases the mineral's total absorption by up to 3 times. Combining vitamin C with plant-based iron is the single most effective clinical strategy for bypassing anti-nutrients and maintaining healthy oxygen transport throughout the body. We see the same anti-nutrient interference when extracting zinc from whole grains, legumes, and nuts. Zinc plays a non-negotiable role in maintaining a robust immune system and synthesizing DNA, but its bioavailability from plant sources is severely compromised by those exact same phytic acid complexes trapping the mineral. For decades, nutritionists struggle to overcome this bottleneck. The solution lies in the allium family of vegetables, specifically garlic and onions. These pungent, aromatic bulbs are rich in a unique class of highly volatile sulfur-containing compounds. Sulfur compounds actively intercept and bind to zinc ions first, physically outcompeting the larger phytic acid structures. This chart tracks cellular zinc uptake. Adding garlic to the meal outcompetes anti-nutrients, climbing cellular absorption by over 50%. These pungent aromatics act as active biological decoys, rescuing trapped minerals from their plant-based inhibitors. If we zoom out from the microscopic cellular mechanics of the gut and look at the practical reality of our dinner plates, a clear pattern emerges. Throwing a random assortment of isolated ingredients into a bowl does not guarantee biological vitality. Our meals have to be constructed with purpose. This advanced clinical pharmacokinetics is a direct reflection of traditional culinary wisdom. We see it in the Mediterranean practice of drenching salads in olive oil, the Middle Eastern tradition of squeezing lemon over falafel, and the Indian practice of cooking legumes with robust garlic bases. Long before clinical science could map micelle formation or the electron transfers of ascorbic acid, diverse cultures around the globe were already intuitively leveraging food synergy to create nourishing, balanced meals. It is time to stop viewing our diet as a collection of isolated macronutrients and numbers. By mastering these biological combinations, we transition from merely eating healthy food to ensuring those nutrients are actively utilized by ourselves.